This video is about how to solve a probability problem involving 3 independent events. 3 people, namely Alvin, Sam, and Jess, work independently to break a code. The probability of each of them breaking the code is given. As the 3 of them are working independently, one's probability of breaking the code is not affecting the others. We have to find the probabilities that none of them break the code, exactly one of them breaks the code, and at least one of them breaks the code. Before we look into each case, let's use a tree diagram to list out all possible outcomes first. These outcomes include all of them breaking the code, one of them breaking the code, 2 of them breaking the code, and none of them breaking the code. Part A. We need to find the probability that none of them break the code. So we are looking at this outcome. Since the events of them working on the code are independent, we can use the multiplication law of probability to find the answer, which is equal to the product of the probabilities of all events. In this case, it's the probabilities of all 3 of them not breaking the code. So the required probability will be 1 minus 0.4 times 1 minus 0.25 times 1 minus 0.2. And the answer is 0.36. Part B. What is the probability that exactly one of them breaks the code? That means we are looking at these 3 outcomes. The probability that only Alvin breaks the code, or only Sam breaks the code, or only Jess breaks the code. The sum of these 3 probabilities will give the answer. Only Alvin breaks the code means that Alvin breaks the code, while Sam and Jess do not break the code. The way to find this probability is similar to Part A. We find the product of the 3 independent events, that is 0.4 times 1 minus 0.25 times 1 minus 0.2. Similarly, the probability that only Sam breaks the code is 1 minus 0.4 times 0.25 times 1 minus 0.2. And the probability that only Jess breaks the code is 1 minus 0.4 times 1 minus 0.25 times 0.2. So the required probability is 0.45. Part C. We need to find the probability that at least one of them breaks the code. At least one of them breaks the code includes the events that all 3 of them break the code, any cases where 2 of them break the code, and any cases where one of them breaks the code. That is, these 7 outcomes. We can work the answer as in Part B by adding up the probabilities of these 7 outcomes. Or in a simpler way, subtracting the probability that none of the 3 people break the code from 1. We've already found the probability that none of them break the code in Part A, which is 0.36. Therefore, the probability that at least one of them breaks the code is 1 minus 0.36, which is 0.64. That's it.